So we're going to talk about variable exponents now. When you go through and you solve anything that involves variable exponents, the biggest thing with that is you just have to literally follow the rules of exponents. So for instance, if we take a look at this first one right here, you'll notice that it says 4a to the x over 2a to the x plus 2. Well, the 4 and the 2 are just coefficients, so we can just reduce those. So 2 goes into 4 twice. And then now the variables, okay, if you have a and a on top of one another like that, that means you subtract your exponents. So I'm going to do exactly that. I'm going to write it as a to the x, so that's the top one, minus the bottom, x plus 2. And then we have nothing left on the bottom there. So it becomes 2a x minus 2. Now the x is obviously canceled, and you get 2a to the negative 2. And now you have a negative exponent right there, so it becomes 2 over a squared. And there you go. So let's try another one. Now this one got, I don't know what happened to this one. It says 2a times a to 3m. Alright, so what do we do here? Well, you notice that we have a's and a's, so we can combine those together. Now it's not just a to the 3m. You got to remember every number and variable has an exponent. So this exponent is 1. So what do? We add exponents to a to 3m plus 1. Alright, sounds good so far, hopefully. So let's get rid of this. Alright, so let's look at this one. So it looks like I can do a little distributing up on top, so it becomes a to the 4x plus 4. So I can distribute that in. B to the 3x plus 3 over a to the 3x b to the negative 3. So next I'm going to, just like we did over here, I'm going to subtract my exponents. So it becomes a to the 4x plus 4 minus 3x. Combine these, it becomes b to 3x plus 3 minus negative 3. So simplify, it becomes a to the x plus 4, b, let's see, we got a little same change, so it becomes 3x plus 6. And there you go. Okay, so hopefully that makes sense, but like I said, the biggest thing is you just have to go through and quite literally follow the rules of exponents. So let's take a look at this one. It says if a to the 32nd equals a to the 2x times a to the 6th, then what does x equal? Well, let's start out by, I can actually simplify that first. So it becomes a to the 32nd equals a to 2x plus 6. Okay, now what do I do next? Well, I'm trying to figure out what x is. Well, what you're going to do is you're going to use this little idea that says if a to the x equals a to the y, then x has to equal y. Okay, so hopefully that makes sense. If I have a number to an exponent and this equals the same number to an exponent, those exponents have to be the same. And so what we're going to do is we're going to use that idea. So if I have a variable, so like a to the 32nd, that equals a to the 2x plus 6, therefore this has to be true. And sometimes you can write, sometimes people like this, you put a little 3 dots right here, it looks like a triangle, it means therefore. Since that's true, then this has to be true. So now I can just subtract. 26 equals 2x, so x equals 13. So this little trick over here is really important in that situation. So let's try another one. So this one says 3 to the 2x equals 81. And I'm trying to figure out what x is. Now we can go through and guess and check. It probably wouldn't be terribly difficult to guess and check, but how would I figure that out mathematically or algebraically? Well, what I could do is this. So it's 3 to the 2x. Now I'm going to rewrite 81. And so I'm going to rewrite it as 3 to the 4th power. Now, why did I do that? Well, the reason why I did that is because of this rule over here that we just talked about. And with that rule over there, now it says a to the x equals a to the y. Therefore, 2x equals 4. So x has to equal 2. Okay, and that's a pretty common strategy right there, is to rewrite both sides so they have the exact same base, and then simply use this little idea over here to solve. Okay, so let's take a look at this last one. Okay, same sort of idea. Okay, now I'd love to be able to combine these over here on the right, or pardon me, on the left side of the equal sign, but I can't. But what I can do is this. I'm going to rewrite 2 to the 4x, but 4 is the same thing as 2 squared. And 8 is the same thing as 2 to the third. Okay, so this and this up here are exactly the same. Hopefully you agree with that. Now let me simplify. So up here is 2 to the 4x over 2 times 3 is 6, 2 to the 6 equals 2 to the 3x. Okay, now again, I'm kind of getting towards where I want to use this rule over here, but I can't quite yet. But on the left, you notice that I have this situation where I can subtract my exponents. So it would be 2 to the 4x minus 6 equals 2 to the 3x. Now I can use this rule over here. Therefore, 4x minus 6 has to equal 3x. Alright, so if I subtract 4x over, I get negative 6 equals negative x, so x has to be 6. And there you go. That's how you go about solving problems that involve variable exponents.